The condensate collecting in the bottom of the condenser will ideally be at the same temperature as the steam exhausting from the turbine. In this situation, it is only the latent heat that is transferred from the steam to the condenser cooling water as the steam condenses. The actual temperature of condensate in the hot well is probably within the range of 80 to 100 degrees Fahrenheit, depending upon the vacuum in the condenser, and this in turn is dependent upon other conditions such as cooling water temperature. By the time this condensate enters the boiler as feedwater, the temperature will be in the region of 400 to 500 degrees Fahrenheit, thus requiring less heat to be added in the boiler. During its passage from the condenser hot well to the boiler feedwater inlet, the condensate receives heat from a number of sources. Initially, a small amount of heat is picked up as the condensate passes through the steam air ejector condenser and from here through the gland steam condenser. In both cases, this heat recovery improves efficiency as it condenses ejector exhaust steam and leak-off gland steam. The condensed steam is then routed back to the condenser hot well. A drain cooler is often located here and uses condensate to extract heat from water returning in the heater drains. The condensate then passes through several feedwater heaters where heat is added by extraction steam. In this particular scheme shown here, we have two closed type heaters and one open heater where the extraction steam comes into contact with the condensate. This vessel is known as a de-aerator, as the mixing of steam and water liberates any dissolved gases, principally oxygen, from the water. We'll be talking more about the construction and function of feedwater heaters in the next segment. The pressure inside the de-aerator varies with the extraction steam pressure. At full load, this is likely to be, say, 150 psi. However, at lower load, this pressure would be considerably lower. Often, the de-aerator is located at a high elevation in order to provide a positive pressure to the suction of the boiler feedwater pump. The boiler feedwater pump draws condensate from the de-aerator and pumps this through further closed feedwater heaters, one in this example, and on into the boiler. We have, in fact, two pumping loops to transfer the water from the hot well to the boiler. First, the condensate pump pushes the condensate through the coolers and closed feedwater heaters and up into the de-aerator. In order to achieve this, the condensate pump must operate at a pressure of about 250 psi. This part of the system, as you would expect, is known as the condensate system. From the de-aerator onwards, we refer to the continuation as the feedwater system, which operates at much higher pressure. The pressure developed by the boiler feedwater pump must be sufficient to overcome losses in the piping system, plus the pressure in the boiler itself. This means that the boiler feedwater pump discharge pressure must be about 2,000 to 3,000 psi, depending upon the particular installation.